Hello guys, today we are going to see about scoped lock in C++. So in the previous video we have seen about lockout. So lockout is nothing but RAII class which has the ownership of mutex and lock the mutex in constructor and unlock it inside the destructor. So whenever this lockout variable goes out of scope, the mutex will be unlocked. So this is the basic concept of lockout. And if we have two mutex m1 and m2, and this m1 will be, and if we are having a code like this, one function is using m1 and m2 in this order, and in second function we are using the mutex in reverse order. So here what happens is once the mutex 1 is locked, so one thread is running fun1 function and another thread is running fun2 function. So initially m1 will be locked, then it will be using shared1 resource, then the thread1 will be passed and thread2 will run. So consider this situation. So mutex 2 will be locked and shared resource 2 will be used and thread1 will resume. In thread1 it will try to lock m2, but l2 is already locked by thread2, so it won't resume. It will be waiting till m2 is getting unlocked, and thread2 also try to lock mutex1, but it is already locked by a fun1 function in thread1, so it will also don't proceed. So both the thread will be waiting for an infinite time without proceeding. So this situation is called deadlock. So this can be avoided by, so this should be avoided. How we can avoid? So we are having locking two mutex. If we lock the two mutex in the same statement, then it can be avoided. But logout accept only one mutex. So that's why we have another class called scoped lock. So the scoped lock will take as like more than one mutex or more than one mutex. So in this we are locking both the mutex in the same time. So this statement is not needed, and here also we are doing the same. We are locking the both the mutex in the same time, and inside this scoped lock it will lock both m1 and m2. Here also it will lock m1 and m2. Okay, so here in scoped lock what happens is it will lock the both the mutex at the same time. If one of the mutex is already locked and only one is free, then the thread will be blocked until the other mutex becomes unlocked. So both the mutex will be locked at the same time. So in this function also same. If one mutex is already locked, then it will wait until both the mutex becomes free, becomes unlocked. So this is scoped mutex. Now this is the scoped mutex. So it will accept more than one. Uh, it will accept more than one mutex in its constructor parameters. So if I run this, I'm getting an error actually. So yeah, here it is not, this template is not required. It is this accepts mutex, so this template is not required. We see it is successfully run. So the scope to lock is similar to logguard, but it will accept more than one mutex. And the scope lock is mainly introduced to avoid deadlock situation. So this is the scope to lock. And one more thing, like in scope to lock, we are having more than one mutex. So in both the functions we are having scope to lock. So the scope lock is implemented in such a way that both the mutex will be locked at the same time. If anyone is locked and anyone is unlocked, then both will be locked at the same time. It won't wait. It will wait until another is locked. So if we have the same statement in both, either one will be executed. So here there is no chance of deadlock. So both will be uh, locked at the same time. The algorithm is implemented in such a way inside scope to lock that both the mutex are locked at the same time. So this is about scope to lock guys. Thank you.